Right, now I owe you a little apology over question 4 because I'm pretty sure that actually we did this in one of the warm-up questions a couple of weeks back. So you may well have noticed that, so I'm sorry about that, but I'm going to do my own penance by going through it with you anyway. And it's all good practice anyway, even if we have done it before. So statistics is what we need first of all to use a calculator to work out estimates for the mean and standard deviation. We need to put in, and before we do, if we look at, hang on, what am I doing? Yeah, when you go to calculate, there's two different vars. Now if I hit one var, if I hit set, notice that on one var I've got a list of numbers for my x, and then in the next one I've got frequencies, and the other one is two different lists, a list of your x's and lists of your y's. So we're just going to be using, we want frequencies of things, so we're going to be using the one var. Very important to remember to use the one var and not the two var, or you will get the wrong answers. So list the list of the actual numbers that we're going for. It's an estimate because we don't know the real temperatures. We know that there were 12 between 11 and 13, so we take the midpoint as being our number. We take the midpoint of 13 and 15 as being 14, and the midpoint of 15 and 17 as being 16. Then we go across to the other side, and now we put the frequencies in here. So it's 12, 14 and 4. And then it was the one var that we wanted, wasn't it? If we hit that, the x bar, that is the mean. So the mean is 13.5 to 3 significant figures, 13.5 13.5 degrees Celsius to 3 SF, and the standard deviation, which I can put just here, is that symbol there. The standard deviation of x is what this bit here is saying, is 1.36 degrees to 3 significant figures. Okay, now use linear interpolation to find an estimate next for the 10% to 90 percentile interpercentile range. So we need to find where 10% is and where 90% is within here. We have got 12 plus 14 plus 4 is 30 results. So 10th percentile at 30 over 10 equals the third result, and 90th at 3 times 9 is 27th. So we need the third result in here within this. Now the width of this range is 2, so I just want the third out of 12, so 1/4 of the way through that group width of 2. Once I've done that, I need to add it to 11, because that's where, if it was nowhere into it at all, it would be 11. So 3/12 of 2 plus 11 will give me my 10th percentile. Put that into the calculator and you should get 11.5. Do the same thing for the 90th percentile. So here we want the 27th, or we've got 26 there, so it's the first one in there. So it's 1/4 of, again, that group width is 2, and we're going to be adding that to the beginning of that class is 15, and put that in there, and that should give you 15.5. So our range, though, do not write 11.5 to 15.5. That doesn't get you full marks. That gives you more information, but the range just wants to know how spread out they are for that middle 80% of your data. So you do 15.5 take 11.5, which is 4 degrees Celsius. Finally, we need to estimate the number of days in September where the daily mean temperature is more than 1 standard deviation greater than the mean. So 1 standard deviation greater than the mean would be 13.5 is the mean, plus 1.36 as our standard deviation. So we're talking at 14.86. So we're wanting to know how many days. 14.86, which is going to be here, isn't it? Just before we get to the 15. So we're going to have just that tiny proportion there. What is it? 15 take 14.86 is 0.14. So we're talking 0.14 out of the whole width of 2 that you've got there. Multiplied by 14, because you've got 14 of them. So 0.14 over 2ths of the 14 frequency. And if you put that in there and then add 4, because we've got all of the 4 from there, that should give you 4.98, which is very close to 5 days. So 5 days should be how many you estimate. Alright, so here's a hypothesis testing binomial distribution jobby. May, is it May? I call her May. Commutes to work 5 days a week on a train. She does 2 journeys a day. Over a long period of time, she finds the train is late 20% of the time. A new company it takes over. May thinks that the service will be late more often. In the first week of the new service, the train is late 3 times. So you may assume that the number of times the train is late in a week is a binomial distribution. So we're assuming that everything's independent and all of that. So for a binomial distribution, we are saying that we are going to have how many instants? You've got 5 days, 2 journeys a week, and we're talking about 2 journeys a day. So we're talking about 10 journeys, and it's being late 20% of the time. So that's 0.2. So the first thing to do is state your null hypothesis, which is going to be that the probability is equal to 0.2, because that means nothing's changed. She thinks it will be late more often, so her alternative hypothesis is that the probability will be greater than 0.2. Now, before we go any further, let's make a little sketch of what's going on. You've got late 0 times up to late 10 times. The expected mean would be 10 times 0.2, which is 2. So I know that the peak is going to be sort of there. And this is going to be testing at 5% significance level. This is going to be a single-tailed test because she doesn't want to know if it's just different. She thinks it's got more. So we are talking about this part here being, in the first week it's late 3 times, so that is just to sort of there, isn't it? It looks like more than 5% to me. So it's about whether or not this is more than 5%. And if it is more than 5%, then the chance that we get that, and I would have thought that it would be, then we can reject her null hypothesis. It doesn't mean that it isn't true, because it is more than you would have expected, but it seems like it would be quite likely to me. So now we get the calculator out, we go statistics mode, we go for distribution, binomial cumulative distribution, and now we want the lower tail, the lower end, to be 3, the upper end to be 10, because we've got 10 trials, that's the most that could be, so 10 trials, and the probability is 0.2, and put that in there, and that gives you 0.3222. So the probability that x is bigger than or equal to 3, we can say equals 0.3222, and that is bigger than 0.05. Therefore, there is insufficient evidence to reject the null hypothesis at this things. There is at the 5% level of significance there is not the evidence to suggest that trains are late more often. Okay? Right, remember always to start off with a sketch and all these mechanics things. So we know that what we're looking at is the particle moving on the positive x-axis. So nothing's happening on the y, but I'll just put it in there anyway. And then on the x, we've got something going on, and it says when t equals 0, it's going to be at 15 when the time is 0. And it's just going to be going along, it could be going that way, it could be going that way. It's not going to go up and down at all. And it's a quadratic, and we need to know the values of t when it's instantaneously at rest. So in between that, it's going to change direction, isn't it? So when it's at rest is going to be when the velocity is 0, and they're saying that that's the velocity there. So velocity equals 2t squared, take 9t plus 4, and that is equal to 0, which means we need to factorize this. So if we do 2 times 4, that's 8, isn't it? So we want two numbers that multiply together to make 8, but add to make negative 9. So it's going to be negative 1 and negative 8. Now in order to factorize that, I'm going to write 2t squared, then I'm going to split my minus 9t into negative 8t and negative 1t, and then I'm going to do single bracket factorization. I can take 2t out of both of these to give me negative 4 there. So that means I know the other one's going to be t negative 4. What do I have to times these two to get them to t negative 4? Negative 1. So that means that my brackets are going to be 2t minus 1 and t minus 4 equals 0. So what would make the brackets equal to 0? Well, if t was worth a half, because 2t would equal 1, wouldn't it? So equals a half, or 0.5, and t equals 4 would make that one 0. So 0.5 and 4 get you your 3 marks there. Now part B, and I'm going to do that over here, the acceleration of p when t equals 5. Now before we go any further, we just need to think about what's happening with distance, acceleration, and velocity's in the middle, isn't it? And the clue to all of this is the units. You've got meters divided by seconds, you've got meters divided by seconds divided by seconds. So what that means is you need to differentiate, because we do that by dividing by time in this case, which is what you've got on the bottom here, isn't it? Differentiate, and then going the other way we need to integrate. So to find the acceleration we need to differentiate that. So if I say acceleration equals dv by dt, then if I've got v equaling 2t squared take 9t plus 4, I'm going to add 1 to the power. No, I'm going to take 1 from the power. I'm going to multiply by the power to give me 4t, and the power drops by 1. The power drops by 1, and we multiply by 1 gives us -9, and then we lose the number. So it's 4t minus 9 when t equals 5. A is going to equal 4 times 5 take 9, which is 11 meters per second squared. So that's part B, all 3 marks done. Now it gets a little trickier when we get on to the total distance covered. The first thing to do is we need, because we're talking about distance, we're going to need to integrate the velocity. So we can say that distance, which is normally called s, isn't it? Although quite often people like to call it x so they don't get confused what with the seconds that are around. So okay, so let's do that. If we call it x, is going to be, and there's the, for the integration we use that symbol, don't we, of the velocity, which is 2t squared take 9t plus 4 dt. So then we need to integrate that. So then we can say that x is going to be, the power goes up by 1, doesn't it? And then we divide by that power. So it's 2/3 t cubed. And it's, the power goes up to 2, then we divide by the 2, so 9/2. From 4 we go up to 4t. And then remember that we're also going to have a constant, aren't we? That we're not sure what it would be. But fortunately, they have told us at the beginning that the position of the particle is 15 meters at when t equals 0. So if that is true, 15 is going to equal, if that's all 0, that's going to equal c, isn't it? So we can say that our position is going to be 2/3 t cubed minus 9/2 t squared plus 4t plus 15. Now there's different ways of doing this, but I like to think about it one bit at a time. So there are going to be 4 crucial times. The first is time 0 when it's at 15. Then the next one will be time 1/2 when it's stopped moving and it will start going back the other way. So before we know which direction it's even moving in, we need to plug in t equals 0.5. So if I say t equals 0.5, what I'm then going to do is put that into my calculator, and I'm going to show you exactly how I would do all of that now, because I think this is quite important and this helps out a bit. This is the way I do it and I find it quite nice. So 2/3, and now I'm going to have my t, which is 0.5. I'm just going to put it in brackets because that will make it really easy for me to replace it with other values of t later on. Then come out of that, take 9/2 brackets 0.5 for my t squared plus 4, and I'm just going to do the same thing again, brackets, put the 0.5 in there, and then plus 15. And that gives you x being 15.9583. Now, if you do s to d on that, it does tell you 383 over 24. And you can do a little bit of investigation to realize that that is actually exactly 15 and 23/24. I'm going with that because I think that's quite important. So what that means is that my particle has travelled in this direction a short way to 15 and 23/24. So it has gone so far, just that far. So journey 1, which I'm going to call that, so journey 1 equals 23/24. Right, next part, we then need to travel all the way back until it's stopped again. So I'm going to do this in a different colour just to make it sort of as clear as I can. So from this point here, it's going to go back to when the time is 4, and then it's going to travel back the other way a bit. So I need to know where it is when t equals 4. So in order to do that, I'm just going to put in t equals 4, and I'm just going to whack that into here. So there's a 4, delete, 4. And that is exactly 5/3. So how far has it gone in that time? It's gone, the distance it's travelled, if we go into for journey 2, is going to be 15 and 23/24 take 2/3. And then we've just got the third journey is going to be it going back in that direction until t equals 5. So again, we just pop along to here, we say t equals 5, and you should really sort of write all of this bit out as a bit of working really, but I'm just going to go through it here as you can see what I'm doing. 5, pop the 5 in there, and there, and that gives us 35/6. So for journey 3, we have the distance from 2/3 up to 35/6, which is going to be 35/6 take 2/3. So how can we put that all in the calculator in one go? And I reckon that should all write out like that. Put it into the calculator there, press equals, and it's giving me, oh, I've got something slightly different to what I had before. Hang on, and that's because for some reason I put 2/3 instead of 5/3 there, haven't I? So that should be 5/3, that should be 5/3. If I go back here, sorry about this, then I get 233/12, which is what we should have. So 233/12, and if you hit S to D on that, that gives us 19.4 meters to 3 significant figures. All right, okay, see you next time for the last 3 questions. Actually, the last 2 questions.